I had some questions about voltage drops, so I put together a little video here, a little demo using 5 resistors. And in the first video clip, the resistors have this resistance, and this time I measured them. For instance, the second one on the left, 9.95 K, the band reads 10 K. Of course, that's well within 20%, but I thought I'd display the resistors this way, the actual resistance read by an ohm meter. And the trainer has a positive 12 volts and a negative 12 volts, and I'm going to put that at the ends of this string of resistors. And across that string of resistors, it does not quite read 24 volts. It reads 23.57 volts. Okay, the first thing I'm going to do here is measure the voltage across all the resistors. That's the supply we have. Now here are the voltage drops across each of those resistors. This resistor here is the 675 ohm. And the last resistor here is the 328.3 ohms. Now I'm going to measure the voltage from the negative 12 volts all the way across, and you'll notice that the voltage is increasing in proportion to the voltage drop of each resistor. Here's the same demo, but with the wiring diagram. Here I'm measuring across the resistors, and now we're going to take a look at each voltage drop across each resistor. Okay, now I'm going to measure the total string starting with the negative probe of the meter at negative 12, and we'll just read across. And again, this voltage is increasing, but in proportion to the voltage drop of each resistor. Now this is the string we've been using. Now I'm going to swap a couple of resistors, the 10K and the 22K, and we'll see what happens. Okay, now I'm going to swap those two resistors in the string, and then we'll measure in the same order the voltages we did in the first demo, starting all the way over at the right. First voltage drop. Here's that 675, it did not change. There's our 22K. Now we're going to measure from the right again, but go across all the resistors, and again the voltage drops we're reading increase with the voltage drop across each resistor. Okay, here's the same demo, but with the wiring diagram. Here's our voltage drops. And notice we got the same voltage drop because it's the 10K resistor, but now it's in a different position. Likewise with the 22K, same voltage drop, but now it's in a different place in the string. Okay, now we'll measure, starting at the right again, all the way across, and the voltages increase with the amount of voltage drop across each resistor. In circuits, many circuits need more than just positive voltages. They also need negative voltages. And a bridge setup is also a good way of doing that. Let's say that I'm going to have a circuit and we're declaring this point as the common ground for the circuit. So that means we're going to measure everything from right at this point. Let's take a look at the demo and see what that looks like. Okay, now I put the negative lead on our common ground point. And now when I measure the voltage drops on the two resistors to the right, we get a negative voltage drop. And now when I go to the left, we have positive voltages. Here's that demo with the wiring diagram. And when I measure the resistors to the right of our common ground, we have negative voltages. And when I measure the resistors to the left of the common ground, we have positive voltages. I hope this video helps you understand what a voltage drop is, and also how useful a resistor bridge is in controlling and coming up with various voltages for circuits. Thanks for watching.